Hello， 大车辆，啊，控制一下，
控制一下，错一下。
Then control limits are derived from the natural process variability. Since we compute the natural tolerance limit upper 3 sigma and the lower 3 sigma, the tolerance limit of a process. Specification limit are determined by externally for so for a customer or designer. So the question is any relationship between the specification limit and tolerance limit? 现加来还是要现加？现加。Is any relationship between the tolerance limit and the specification limit? 对不对？你知道我在问什么？不知道。你知道我在问什么？
这两个有什么关系？
我好像不太能讲话。
Then yes. Okay, shut it up, man.
我不知道，可能是这个有什么关系
Is any relationship? Yeah, you got me. You shut it up, man. Is any relationship? Speak up. 杨婷。
可能是这个有点关系。
COW. No. Specification limit are determined by customer or designer. Designer will be R&D department. What about the natural tolerance limit? Pre-standardization is yes, exactly. So it is determined internally. Natural limit, it is how capable your process is. So there's no relationship. There's nothing to do between them. Nothing to do with each other. Let me say it again. Specification limit is nothing to do with the tolerance limit. Tolerance limit is nothing to do with specification limit. They are independent. Get it? Okay, thank you. Then, no mathematical or statistical relationship between the control limit and the specification limit. Okay, then national subgrouping. In the middle of the page 229. Export shall monitor the between sample, right? This export to detect the between is any difference between the export. And that is evaluated between variability. And then the R chart measures the within variability, right? Each point. This evaluate the within. R is the range within a sample. So we're going to monitor is any significant or random fluctuation between samples. So that is used to evaluate the within variability. That is to evaluate the between variability. So R is used to measure within. X bar used to monitor between. So standard deviation estimate of the sigma used to construct the control limit, calculate from the within sample variability. Yeah, of course. So it is not correct to access sigma using this. So it's totally not correct. So it is not correct to estimate that is between. this X double bar in the center and the MN by 1 lost degree of freedom. So it cannot be done. No, it is not logical to do so. This is not logical to do so. It is only derived from the within sample variability. Within sample is from the R. We would like to R used to estimate sigma. So how can we do that? Since R divided by D2 equal to the sigma, and R is range, is replaced by R bar. So put the caret on the top of the sigma. So that is used to estimate the within sample variability. So cannot use this. No, it is between. It is not logical to use this formula and the standard deviation to evaluate the sigma, to estimate sigma. No, it's not logical to do so. The guideline for control shot designs, page 2230. So control shot design requires specification of sample size. Typically, we use a 3, use a 5, use a 6 or 7. Then control limit width. Typically, what kind of control limit are used? Mr. How can I call you? Kim. CAD. K-A-D? K-E-D. Do your national soccer team go to the World Cup? No. Which country are you? What? Haiti. I do have a really strong soccer team. No. Okay. You can say yes. Actually, have you ever made the World Cup before? Really? Yes, stronger than Taiwan. Better than Taiwan. Yeah, of course. How many times they ever made it in World Cup? One time. Oh, not so strong. Barely make it. So, do they survive in the in the preliminary round, in the first round? No. Yes. Then they advance into the second round. Oh, very special. So how much money did they spend to make it? No. All right. Okay. Then. So control limit. Typically we use the 3 standard deviation. 3 standard deviation, so going to cover up to 99.73%. 2 standard deviation going to cover up the 95%. 1 standard deviation cover up the 68%. 不是不能讲话。
暂时过了。
Okay.
都你在讲。
Sampling frequency, it depends. Typically use the 30 minutes as a sampling frequency or 1 hour. We take one sample every 30 minutes or every 1 hour. So exact solution requires detailed information on statistical characteristics as well as the economic factor. That is known as an economic design. Sample size is the frequency. So treat this as objective.
这个也要写。 Treat this objective as a function of the sample size, function of the K,
how many standard deviation are used, and the frequency, sampling frequency. The problem of choosing sample size and the sample frequency is one of the educating the sampling algorithm. So for X bar chart, choose a sample as small as possible. Is consistent with the magnitude of the process mean. One is trying to detect. So if you like to detect larger mean shift, the sample size is not necessary to be large. However, we would like to detect a small mean shift. The sample size should be larger. Like to detect the larger mean shift, the sample size can be small. If you like to detect a smaller mean shift, the sample size should get larger. Why we should get larger in the sample size? Since the sample size get larger, we increase the sample size. That means we have a more power. Power increases. But more power, then we can detect the small changes. Why? Since the smaller mean shift, then that means there's we will commit type 2 error easily. So beta. Smaller mean shift, that means the beta increases. In order to detect the beta, then we need to increase the power. In order to increase the power, sample size should be increased. So this is the logic. So for moderate to larger, relatively small sample size are effective. As I mentioned, larger mean shift or moderate. The larger or moderate mean shift are present, and sample size can the small sample size will be faster.
要拍到完，不用手抄是奇怪的。
看不太到，是有肖像权。
应该写不错。
啊
What power 不是 one minus beta？
？Yes。
那为什么 beta？
两个都一起增强。
Things out now. In which case? In which case? I would say so. Things are smaller mentioned, right? And beta is larger, right? The beta is larger. In order to decrease, in order to detect it, sample size to increase, to reduce the data and the power increase. Okay? So this is the consequences. This is the consequence.
我们为了降低贝塔，
你要那个 Mr. Yellow tell her the logic.
就是好像是，
大声一点。
是那个我们要降低那个贝塔的话，
我要讲完。
来看一下啊，我们今天的 mean shift 代表说什么？ 形而误差很可能会容易犯错，对不对？对吧？形而对吧？那你形而容易犯错，代表什么意思？代表什么意思？我的 power 不够，对吧？
对。
那我要去侦测这样的小的偏移，我 power 不够怎么办？就去增加样本，让 power 增加。大家逻辑是这样，听得懂吗？因为来偷看一下样片，我今天的差距那么小，我比较容易犯形而错误，对不对？那今天形而错误代表说我的贝塔会增加，那问题是说我们又要把它能及时找到，这时候怎么办？我只有样本增加，样本增加 ，power 增加，这就是这样。哎 ，good question. So for small samples are is relatively insensitive to changes in the process standard deviation.
我在他面前，
不要，
来，
分了，电视在哪？电视。我就讲不下去。Yes。我没有带手机。礼拜5的15号是没有陈凯莹老师的重要，我只是插花。对，礼拜4或礼拜5我就尽量make it嘛，对不对？我这个我可以。
哎，那2天超级的。
12月多少？14号。
15号我申报班剧了。
真的吗？没关系，应该可以。
没投票，
尽量。因为我是18号。
班剧都在我身上。
那你要吃什么？老师，你想吃怎样的？
不要问我，陈凯莹比较重要。
他说我们挑。
不要问，你们决定就好。
然后他说，
那就
我只是插花的。
钱呢？
因为我记得我们上次还在长安东路那里，
正
他们讲烧肉。
钱呢？
还是我们这次来点不一样？
对，正在
帮我钱呢？
他会帮我吃
怎么不一样呢？
我整车
今天开一个包厢。
我看到在搬里，
他都是加入我。
是应该这样，好邪恶。
不是，你们上次陈老师是每个人补助你多少钱？300、500、400，不一定。
是吗？
没有那么多啦。
都是一个人付多少？
300
块，超300。因为我现在没有导针啊，我是孤独的老人，没有导针。
怎么可能？
真的我没有导针。
没有3夹。
哎呀，所以猪还要。
你闭嘴。
还有我们，还真是火锅。
没有，我希望你们4年级能多一点，就是应该这样讲，要就业的就赶快去就业，要
啃老的赶快
实习，要出国就赶快出国。
都要出国。
你要去哪个国家？
中国。
哦，对，学音乐啊。哦，你是申请学校的吗？对。好的，那什么学校？叫做没有那个学校还蛮好，就是叫做
维也纳音乐学院。
叫威WEIN。哦，那个学校世界排名比我们学校还高。
真的哦。
很多学校比很多啊。
它大概世界大概我记得在300多。
那个吗？
加油。
我们学校最高级。
Okay, then, right? The R chart is a relative insensitive to changes in the process standard. For large sample, the S or S bar are favored choice. So when sample size is larger, when sample size is larger, then S or S square chart operate. So we're going to use it instead of R when sample size get larger. So that there's so gonna skip that. There's a probability limit that seldom people use that for now. allocated
礼拜五啊。
所以，但是有人那个会
Okay,
有些
so
是
this is 26.
那天我们要来，所以应该就礼拜四。
Where's the probability?
但是礼拜五要来，所以就礼拜四。假如礼拜四有。
Yeah, this is right here. Okay.
还是礼拜五。
Look at the example 6.2, changes sample size. Hello, pay attention to example 6.2, 1 minute. 在读那个6.2 6.2, read the example 6.2 now.
这个
So to illustrate the above procedure, consider the X bar chart and the R charts developed for the hard-baked process example 6.1. These charts were based on sample size of 5. Originally, suppose that since the process exhibits good control, the control engineer personnel want to reduce the sample size to 3 wafers in order to save cost. So from here, so NO equal to 5. The R bar is checked from the table 6. Is 0.32521. So from the table we have the D2 is 2.326. And the D2 corresponding 1.693, since we would like to reduce sample size from 5 to 3. To check those numbers now on the bottom, please. To make sure you can check the number correctly. Actually, D2 is 1.693, am I right? Yes. You can do that. D2. 3, 1.693. Have you found it? Reduce the sample size from 5 to 3.
3.
So therefore, the control chart, control limit on the X bar chart are found in equation 6.12. So we can use the D2 divided by D2, the D2 new divided by D2 old. So you can see that when set. Is there any question? No. Okay, question. If we reduce the sample size, what is the change of the control limit? Hands up. What do you think? We reduce the sample size. Then the control limit will get wider or get tighter. Mr. Dodger, what do you think? Get wider or get tighter? Birdie? How about you? Size. Okay, when we reduce the sample size, the control limit will get wider or get tighter? Excuse me? Wider. Why? Yeah, exactly. Bingo. Very good. Since the variability increases. Right? Sample size. That means sample size reduce. Variability get wide. Why? Is that sample size reduce? Yeah. Get it? Standard deviation. Good. Okay. So this is the updated upper control limit, the updated lower control limit. For the R chart, it also perform the updated, do the limit update by yourself. Right? The same. It's right here. You perform the update on the control limit. Then we look at the graph. Page 233. Figure 6.7. Recalculate control limits. Then, well, starting from sample size 25, we just reduce the sample size. Then you can see the upper control limit and lower control limit. Then get wider, right here. You see that? Get wider. You see that?
wider 就变宽了。
Okay, then we move to the probability limit on the X bar chart and the R
你
chart.
这个刚才看过去，就是它是新 new 的第一个，那你可以看表。
So, so we need to check another table on the box if we like to use the probability limit. But first of all, it's easy to choose a probability limit for X bar chart. Since the X bar is approximately normally distributed, we may obtain the desired Taiwan error by indicate alpha. Then choosing the multiple sigma for control chart like a k equal to z alpha over 2. Since it is a two-sided, then z alpha over 2 is the upper alpha over 2 percentage point of standard normal distribution. Like, if we choose alpha 0.002, then z alpha over 2 z 0.001 equal to 3.09. Make sure you can get this number right now. Check on the box. Okay, do it right now, everybody, to make sure you can find this number. In the exam, there's no way you're going to check the note and find the answer for yourself. You need to practice before explanation. Can you find it? Z, this is Z.001. 那个小卷毛真的没来。
对啊，胖，
我知道啊，
对啊，他没来。
他是怎么会啊？谁跟他比较熟？还是慰问一下，看到底发生什么事。
我也问。
Did you find that? Mr. Chen. I should check the CDF, the 0.9999.
CDF
999, right? 0.999.
这个啊，
Okay, 3.1 around. Then, how about that? We like to count the shot. The alpha.
301。
Okay,
3.1。
can you give me this number? Can you get this number for me, everybody?
0.13.09。
Yes.
0.1。
What is the number? 14? This is 0.86. 86有没有找到？大概，approximately 大概，
0.1。
嗯
0.1是
，0.86。
哦，0.8。
1 point something, right? Okay, it's almost 1 point something. Yeah, it's something like that. You do this when during the examination, right? So, and consequently, this is very little different between this control limit and 3 sigma control chart. So, may also use the R chart using probability if alpha equal to 0.02. So divide by 2.001 and the 0.99 percentage point of distribution of the relative range. The relative range is this is defined as R divided by sigma. So this point obviously depends on the subgrouping sample size n. Then denoting this point by the W.001n, 0.999n, estimated sigma divided by this is R bar divided by D2. Yeah, then so UCL we can use the D.999 and the D.001. This is probably the limit, so you can check it. Okay, this is only for your reference. You can compute that. However, this nowadays seldom scientists or engineers use that very often. Okay, 6.2.3. Okay, page 235. So chart, there's a chart based upon the standard value. If the center line mu is given, if mu is given and the sigma is given, then there's no necessary to check those parameters on the back. A2 is not necessary. So based upon the standard value, then mu and the UCL mu plus A sigma, this is 3 divided by square root of n, and this is minus A sigma, the A equal 3 divided by square root of n. That's also attached on the back of the table, A. Yeah, look at that. On the back, this is A. Table 6, yeah.
Table 6.
You see that? The first column. The first column. Table here. First column, right? The first column. Then the upper control limit, lower control limit, this is the D2 sigma, the D2 and D3. So there's also D2 and D3 attached on the same page. Okay, then 6.2.4. So interpretation X bar and R charts. First one, cycle on a control chart, 6.8. The cyclic pattern occasionally appear on the control chart. This is in the figure 6.8. A typical example, highlighter. Use a highlighter. Okay? Cyclic pattern. This example typically shown in figure 6.8. Such a pattern X bar may result from systematical environmental changes, such as temperature, operator fatigue, regular rotation of the operator or machine. First of all, we change the shift. This is a day shift or night shift, then it's fatigue. Then this is an example. And then or fluctuation in the voltage of the pressure or some other variable in production equipment. So our chart will sometimes reduce cycle because of the maintenance schedule, like production maintenance. Yeah, like fatigue. Yeah, when the maintenance and fatigue, and the maintenance fatigue. So this is called PM, after PM. production maintenance, known as SOP.
到满血，到满血。
And fatigue and resulting excessive variability. In one study in which this another was invoked, systematic variability is a fuel volume of the vat of metal container was caused by the on and off cycle of the compressor of the filling machine. Like a Coke or Pepsi. You're gonna fill the bottle of the Coke, or like this kind of the bottle, we call the paper box. Then they're going to add the pressure on the refueling machine, on and off. So that will be a similar pattern of the cycle right here. Second, the mixture. Okay, look at that. The page 236, figure 6.9. When you look at this, you might envision, you might skeptical, is that possible a mixture of two different populations? It might be. Like this. Might the two different distributions, something up very close to the upper control limit, and the other portion or the other half close to the lower control limit, so it can be considered is a possibility of the mixture of the two different distributions. So sometimes going to in the upper level, the other half remain at the lower level. We call it mixture. The third one, the 6.10 as shift. Originally, it going well on a stable level. Suddenly, it just lower a little bit to a lower level. This is a trend in the trend increasing, or call it increasing trend or decreasing trend. Yeah, stratification pattern, this is quite special. On the figure 6.12. Figure 6.12. Called the stratification. Highlighter, please. Stratification or tendency for the points to cluster artificially around the center line. Look at that, gentlemen. Is any point fluctuate close to the limit? No. Close to the upper? No. Close to the lower? No. That's strange. It is not normal. It is abnormal. So called the stratification. So that is to say, we know that there's a marked lack of natural variability. If it is natural fluctuation up and down, sometimes close to the center, sometimes close to the boundary, then in the observed pattern, one potential cause of this stratification is incorrect calculation of the control limit. No, this stupid, this incorrect control limit. The pattern may also result when the sampling process collect one or more units from several different underlying distributions within the each subgrouping. Yeah, that's strange. Sometimes it's a subgrouping, so it contains different distributions, up and down, up and down. So sometimes it's right here, sometimes it's right here, and then we take the average. It's close to the center, right? Could be the two distribution like that. However, eventually end up with like this. Why? Since each point representing the mean, right? And then there could be the distribution up and down and something in the middle. When take the average, the group 1, group 2, and group 3, it end up with all the points that close to the center line. You get it? So this is quite similar to the first one, so called the stratification. Okay, I stop here, and so examination going to cover from chapter 1 to chapter 5. Let me say it again. You can bring all the book, you can bring all the class note, and no computer, no pad, and you need to bring your calculator, and no cell phone allowed. Okay, I see you next week. I will be in Europe next week, so the teaching assistant going to be here. No, not in this room. It must be in the I think in the 430, I believe.